Alright, so today we are doing volume. This chapter is still from the blue book, from the yellow book if you're following. We're going to start with volume of rotating, and then we'll do volume of cross sections. Okay? This is all old news for you guys, of course, except Andrea and Sophie. So, the textbooks, remember, they like to give a lot of different formulas. I kind of taught you guys last year that if you just remember this one, then you just eliminate the things that don't come. So, they will usually give you one or two functions, okay? And then the function may or may not close in a little space. And then what they're going to ask you is, what is the volume that would be given if this function would start to rotate, okay? So imagine like the stadium for the Dolphins. So you kind of have like the back wall, and then you have like where the seats are, and it creates a space. And then if that rotates is what you start to create the whole stadium. So that's kind of like the volume that they want to create. Does that make sense? So not every time will it be two functions, and not every time will where you're rotating around be some number. So whenever you're rotating around, let's say, the x-axis, then your c is 0, and then these two pieces eliminate from your equation. Okay, and now you're just doing capital R squared minus lowercase r squared. Okay? Am I missing something from this formula? Hold on. No. Okay. So, sorry, moving back. So that's what I wrote here in blue. There's many instances where there's no C and there's not a second function. So for example, if they just wanted this outer line and this entire space to be taken up, then you'd only have one function, not both. If I only have one function, then this whole second half of this function is gone, and now it's a shorter version. So instead of memorizing 4 different equations, 4 different scenarios, you just eliminate what is not given. Okay? And again, if we're rotating it along any of the axes, then C is just 0, and that part disappears. Alright, so if you are following with the PowerPoint, I do skip a lot of slides in this PowerPoint, so don't be surprised. But I am on slide 6. Okay? So slide 6 says, let me see if I can fit it here. No, you can't really see it. It says, find the volume of the solid formed by revolving f of x. So they want you to revolve f of x, and they give you the function square root of sine of x, bounded by that function and the x-axis. So that function and x-axis. Okay? And then they tell you that they're going from 0 to pi, and they want you to revolve around the x-axis. So you're going to revolve this function around the x-axis. Okay? I'm going to start scrolling up. Ale, do me a favor. Go write this formula on the board so we can keep looking at it every problem that we solve. Okay? So if I want the square root of sine only from 0 to pi, think of the original graph of sine. It's the over and under. Okay? So if a full sine graph goes all the way to 2 pi, half of it going to pi is only that first part that goes over. Okay? The square root function just might make the y values a little different. So we are going to rotate around the x-axis. Here, look, it's on the screen. There you go. Thank you. So just so you know the difference between the r's and why they're r's. They are r's because it represents radius, okay? So looking back up here, if I follow a radius from that dotted line C over to the function, the closer one, the smaller radius, represents the lowercase r. So that would be the function closest to C. And then if you draw the line to the further radius, the longer radius, which is why it's a capital R, that would be the function furthest from C. Okay? So here I only have one function, and my C rotating around the axis is 0. Okay? So this is a nice, easy formula. I am going to write the pi every time. Integral from A to B, from 0 to pi. And then it is, remember, I don't have the C's and I don't have the second R, so it's like taking this portion out and taking this portion out. So it's just R, which is the function, squared. Okay? So it is square root of sine of x squared dx. Okay? Where? The function that was given is this, sorry, it looks like a negative. That's my square root.
No, but like when it's plugging in, the C is 0, but there's still negative column.
So, okay, I see what you're saying in the formula. Although there is a negative there, when we just write the function, we technically don't have to include it because, let's say the C is 0. If I have a negative anything squared, what happens to the negative? It disappears. So you can write it in and it'll end up disappearing, or you can know that it will always disappear and you don't have to write it. Does that make sense? Good point. So now always clean up, just like when we're doing area, clean up before you integrate. So the squared and the square root cleans up.
C is the point of rotation, right?
Right, and since I'm rotating around 0, you don't have to write C. Anytime C is 0, you don't have to write it. Okay?
Wait, and what lowercase r?
If I had two functions, okay, then the lowercase r would be the function closest to the line of rotation. Okay? So we're going to have pi times the integral of sine of x. What's the antiderivative of sine of x? Beautiful. So now I just have pi, and then I have negative cosine of x from 0 to pi, which gives me pi times negative, what is,
0.
right, cosine of pi
And then
would give me z,
which would be -1.
hold on, cosine of pi is not 0, that's sine of pi, sorry.
Oh, sorry, I was thinking of pi, which is my bad.
That's okay. Alright, minus, be careful that this is negative and not messing up with these extra negatives. So when I have pi, this one gives me -1 minus, and then this one gives me 1. So be careful with all those signs, very easy to mess up. End up with 1 plus 1, so my answer here is 2 pi. Okay, that would be the volume. If this item would start to rotate, it would kind of make like a little sphere, and then the volume would be 2 pi. Easy?
Would it be positive 1 minus 6?
Be careful, because cosine of pi is -1, but there is a minus in front. And then we have the minus from f of b minus f of a. And then we have a minus cosine, so that negative goes there. And then its cosine of 0 is +1. Yeah, that's a little tricky with all those signs. Alright. If you're following on the PowerPoint, I'm going to slide 9. Alright, good so far? Okay. Find the region of the volume of the solid formed by revolving the region bounded by graphs. So again, keyword there is revolving, and I know that's going to sound obvious because I'm going to say throughout this lesson, but when you're doing, let's say, the AP test, it's very important to catch that word revolving versus the word cross-section, because that's what lets you know to do one of the two different operations. So revolving, and they give you the first function, y equals square root of x. And then they also give you y equals x squared. Okay, so those are two different functions. And then it says about the x-axis. So that lets me know that, what's my c? 0. I'm revolving again. So I'm going to up it little by little. Okay? Drawing an image is always so helpful here. It helps you see who's the little r and who's the capital R. So remember, square root is like the little teapot arm. And x squared is like the parabola. Okay? Now, I know the parabola goes further, but it's very important to catch, just like when we were talking about area, where they intersect. So yes, the parabola does keep going up here. But I only care about the portion that intersects. So it's this section. And they said to rotate around the x-axis. So which function is closest to the x-axis? The parabola. So that means that the parabola is little r. It's the shorter radius.
No, it would be bigger R, wouldn't it? Because furthest is little R.
No, think, excuse me, the capital stands for like a longer, bigger radius. Okay? And so the square root is further, so that one would be my capital R. Okay? Good up to there? So here I am using more of the formula. I'm just not going to use the c's. So my formula goes pi times the integral. What is my a to b? What's my leftmost point for the intersection? 0. And then how do I find out what my b is? Make them equal to each other. So square root of y, whoops, not of y, of x, equals x squared. What do I do?
Square.
You square both sides.
So it would be x to the fourth, right?
Right. So I have x equals x to the fourth. You can divide by an x. And cube root, what's cube root of 1? So that's what lets me know that my b is 1. So I'm going from 0 to 1. Okay? And now I need to write, I don't have a c, so I'm just going to write my capital R squared. My capital R we said was square root of x. Right, and then the formula has a minus, and then my little r, which is x squared. Squared. Okay? All of this dx. In all of these questions, just like the area questions we did last class, I think the hardest part is the setup. And if you guys remember from last year, a lot of these questions even said set up but do not solve. Because if you can figure out the concept of just how to set it up, they know that you know the calculus. Right. So like Andrea, there was a question in an FRQ that literally just had you stop here. Because if you can understand the concept of how to set it up, they're like, okay, I know this person knows how to integrate. Like, let's just keep going. Make sense? All right, so now just clean this square root and this square cancels. That'll become to the fourth. Yes, we are. In class, for the sake of practice, we will. And now this is a pretty easy integration. Common mistake is forgetting the pi. Oh, what am I doing? Usually they give a point for the pi, a point for the functions and their antiderivative, a point for finding a and b, and then a point for the final answer. Yeah, they give a lot of points on these. Oh, I did, thank you. All right. So finish up this integration. I know this whole part is going to equal 0. Always double check, but you guys see it on the screen? Yeah. Alright guys, did you get 3 pi over 10? Guys, stop talking. 3 pi over 10?
Would it be going to be a square? Oh no, we can see it.
So yeah, it depends where you're looking, because over here, square root is closer and x squared is further, but it depends on where they intersect, okay? It creates that region.
How do you know which figure on the zero is?
Whoever is closest. So I once had somebody who trained me that she had her class. I wasn't a big fan of it, but maybe you guys like it and we'll start doing it. Whenever she found the region bounded, she would put her pen on R and then draw an arrow, and the first graph she touched was little r, and then she'd do it again and the furthest one would be big R. That's how she always did it. I just thought it was a little hard to see with so much writing, but if you guys like it, we'll keep doing it. Cool? All right, I am moving on to slide 12, for those of you following. Yeah, that's all we're pretty much doing until we hit cross sections. Practice after practice, okay?
The different shapes you have to memorize.
Remember the church that you always said?
Oh, the church. How many questions per square foot?
In a moment. Alright, find the volume of a solid formed by revolving. So you get that keyword volume and keyword revolving. This one? Go for it. We have the region bounded by the graph, so we have y equals x squared plus 1. We have y equals 0, x equals 0, and x equals 1. And then it says, oh no, about the y-axis. Oh. All right, so remember how in area sometimes we have to do things with respect to the other variable? That's what's happening right here, okay? These are obviously not our favorites, okay? Again, a sketch is always so useful. Yeah? Okay, so let me see if I draw these in a different color. So it says y equals 0, x equals 0, and x equals 1. So let's say x equals 1 is here. We have x and y equals 0, which is just the actual axis. And then it says x squared plus 1. I know x squared plus 1 is a parabola that moved up 1. Okay? How are we doing? I just drew the 4 functions that they said. So here the parabola is x squared plus 1. The parabola moved up 1. I have y equals 0, which is the x-axis. X equals 0, which is the y-axis. And then x equals 1, which is this vertical line. Okay? So we need to be really careful here because 2 different things are happening. So we're going to have to split this into 2 integrals and then add them together at the end. So if you notice, right here at 1, if I draw a little dotted line, again, we're looking at this sideways, not up and down. Let me even rotate my paper for a second. Okay? If I look at it this way, because I am rotating about the y-axis, from here to here, I'm rotating around the y-axis, and I really only have one function away from the y-axis, okay? But here, in this little triangular looking thing, I have the parabola, which is the closest function, and then I have 1, which is the furthest function. Does that make sense? So I'm going to split this into 2. Okay, I'm going to do the bottom one first. So the bottom one goes, remember, if I'm doing this sideways now, I'm using my y values as my a and b. Okay, so this bottom one, I would write pi. I only have one function, and I'm revolving around 0, so I don't need the c. According to the y, I'm going from 0 to 1. And then what's my only function?
You have to convert it to,
X.
x equals, right?
Right, that one's already an x equals, right? So it's just 1. My only function without a c is 1. Okay? And then instead of dx, I'm doing things with respect to y, it's dy. Are we good with this first bottom portion revolving? Okay? Okay, so this one is the bottom. Now I'm going to add that with the top one. So the top one, I have to do a few things before I can set everything up. I know I'm going to have the pi and the integral. I have to figure out my a and my b. My a is pretty easy to see. 1, I need to figure out what this point is to figure out who my b is. And I need to change this function to have it as a function of y.
Yeah.
Okay? So step 1, I need to figure out what that function is. Excuse me, what that number is. That number would be me setting the function of x squared plus 1 and plugging in 1 into x. So we'd say y at 1 would be 1 squared plus 1. What is that number?
0.
Yeah.
No, sorry, 2.
2.
I subtracted.
That's okay. So I know that the bounds for the next one is from 1 to 2. Good so far? I haven't lost anyone? So I know this is 2.
What is the bottom of the equal?
Well, it's the bottom portion. That's why I put the word bottom. Now I'm going to do this top portion.
Oh, you're separating?
Yeah.
Is there a way to do it without separating?
No, because, so again, remember they teach you with 4 different formulas. So technically, I would have to use different formulas for both scenarios because this one only has 1 function and this one has 2. Okay, so that's why we split it. So, now my function, let me change it. Y equals x squared plus 1. And let's get that x by itself. Okay? So now here, I have to do the formula. So I don't have a c because my c is 0. So I have to do further function squared minus inner function squared. So the further function here is still 1. So I have 1 squared minus the inner function in terms of y is this that we just found. And then dy. And again, this is the top of the image. Okay? Hardest part. We're done with the hardest part. Okay? So now it's just a matter of cleaning. I have pi times the integral from 0 to 1 of 1. Be very careful here. This negative is going to end up distributing. Common mistake, super common mistake on the AP test. Actually, let me draw it here. So I have minus y and then plus 1.
Why is it 1 minus?
So I have this 1 squared, and then since the squared and the square root cancel out, I'm just left with this y minus 1 in parentheses, so I distribute the negative.
Yeah, but what is it?
This one? Okay, so back to the image. For this function is this function of x equals 1, and then minus the inner function is the parabola, which we isolated x, so that it'd be a function of y.
So you have a 1 on the other side.
Right, on this one?
Yeah.
Okay, so this one is the bottom, this like rectangular looking piece. So here, from where I'm rotating, I only have one function, which is the function of 1. So this left side is me finding the volume rotating of this bottom rectangle. This side is me finding the volume of this top little triangular part, okay? I have 2 minus y. Ali, what happened?
Oh, I solved it.
Oh.
And I erased it.
Why did you erase it?
Because like it's gonna be like a hassle erasing all of this. It's getting stuck to like the board. The board's not like really erasing the like ink from it.
Alright, you
Why
should
does it do
have
that?
done 3 pi over 2. I know, it's a pain in the butt. Don't even worry about it.
It wouldn't do that before. That's why.
Yeah, when the cleaner the board is, the worse the marker smears on it. So sometimes I just leave it dirty. Alright, how are we doing? Andrea, you good? You got it? Alex, you good?
Oh, yeah.
Okay, I'm moving on to slide 12. Nope, just kidding. Slide 17. That was slide 12. So it says find the volume of the solid formed by revolving the region bounded by. So again, you have that key word, revolving. And then it gives you the function 2 minus x squared. It gives you g of x equals 1. And finally, we see revolving about the line y equals 1. Whoops, I didn't notice I was always on there. Sorry. So that right there is your C. The moment you see the word about, that tells you who your C is, okay? So we know that C is 1. So again, I always think drawing it helps so much.
I never understood this faster. This means it's rotating around.
Y equals 2. I mean, y equals 1, I'm sorry.
Why
Yeah,
do
it's just from the back.
Yes.
It's a horizontal.
I didn't get that.
Right, so I know it's going to be hard to see for the people watching the video, but put your line, excuse me, put your hand, eyes up really quick. Put your hand where it says rotating around. I know that y equals 1 is a horizontal line, so I'm going to put my hand like a horizontal line, right? If I want things to rotate around this way, this is when it's with respect to x. and then I pick my first x and my last x of where I want it to rotate. If it says rotate around x equals a number, x equals a number is me putting a line vertically, that means I'm rotating around sideways and I need to pick y values so my function is with respect to y. Okay? Sometimes you just gotta hear it a few times. Alright, so that 2 minus x squared, we could also see that as a negative x squared plus 2, which just means a parabola face down that was shifted up 2. Okay? So we have 1 and we have 2, and that parabola faces downward. And then we have g of x, which is 1, so then we have a horizontal line, right.
That means it's revolving around g of x.
Exactly, and then it wants to rotate around y equals 1, which is technically g of x. They're trying to confuse you.
Does that mean when you put it into the formula for like furthest or anything like that, would it be c, the c minus that, which would be 0, right?
Which cancels it out, because we technically do not have a second if I'm just saying this space, sorry, let me get red.
So if the function is the c, then it just cancels.
Then that second half will end up canceling out, exactly. Alright, so that space right there is going to end up rotating around this line, okay? So you can do this one of two ways. Like Alice said, you can realize that when one of the functions that they give you is the same as what you're rotating, when you plug that into the formula, one of them will be c and one will be r, which are the same thing, and they'll cancel out to give you 0. If you know that that happens, you can technically realize that on the formula, you're always going to skip this function entirely because it'll cancel out. So I'm going to show you both for now, but know that you don't have to do that, okay? I need to find my A and my B. How do I do that?
Set them equal, right?
Set the two functions equal to each other. So I have 2 minus x squared equals 1. I have x squared equals 1, and x is plus or minus 1. So that lets me know that it goes from negative 1 to 1. Okay. Now, again, I'm going to show you the whole thing, and then I'm going to show you the part that you can skip when you catch that. So I have c is 1, minus the further function. Be very careful here because the further function has two terms, which is 2 minus x squared, which means I'm going to have to distribute that. And then I can square it. Okay? And then the second part of the formula says minus c, what I'm rotating, which is 1, minus the closer function, which the closer function is technically itself, which again, hopefully you start catching that that will always just cancel out because 1 minus 1 is 0. Okay? So now let's just start to clean this up. Alright. Are we good up to there? Not that I'm going to necessarily take this step, I just want to see if your eye catches it. Does anyone catch a shortcut that we can take? Oh. Yes, nice, David. Okay, so yes, because this is an even function and the A is technically the same number as b, just negative, that means that this portion right here is identical to this portion, so I could technically go from 0 to 1 and double it. Which makes my arithmetic on f of b minus f of a lot easier because the a will cancel out and I just double it. If you catch that, that will save you some time, okay? I am going to go the long route just in case you forget, just to practice. But that is,
So you just put 2 pi in front?
right, you write
And
2
you
pi.
put 0 into 1?
Exactly.
Okay.
So you're cutting what you're doing in half, but then you're doubling it at the end.
I do 1 minus 2 and then plus 1 minus.
Did I make a mistake here?
It says 1 minus 2 and then it says plus 1. On the third side.
Oh yeah, it's -1, not,
Hold on. Let me find it really quick. Alright, so I made a quick little mistake here, so I'm going to fix it. This one should be a plus. When I distribute this negative, this should be a plus. And then 1 minus 2 is a -1. Sorry for that, guys. And now I get to blame that on pregnancy brain. That's going to be my excuse for the rest of the year. And that should give me it still gives me a -2x squared. Okay, yeah, the rest is fine. Sorry about that, guys. Because you distribute this negative right here. Let me show you in red.
Let's do the testing, which is, I think, next week, Friday. I think so. Yes, next Friday.
Alright, if you get common denominator, I'm going to double it now just because you can see that they're going to add up together.
There's something on that thing.
You should get 16 pi over 15. Alright, so the next question is a little bit complicated, but it shows you a little bit of each kind. So bear with me with this question. It's very similar to one of the ones in the textbook that I would always assign. So I'm just going to do one of them with you in class, okay? It gives a scenario of a function, and then it gives 4 different scenarios of how it could rotate, which are the 4 total types of scenarios that you could ever see. So that's why I like this question. So have a lot of space in your paper. Alright, this is slide 18.
16 pi over 15.
Not right now. We're working, Mark. Alright, find the volume of the region bounded by the given functions and revolving around their appropriate line. So the functions are y equals 2x squared, y equals 0, and x equals 2. Okay? So let's start off by drawing that.
Can you tell us what it refers back to?
There's 4 different questions. I'll do one at a time. Okay. So 2x squared does create that parabola. Okay. And then they say y equals 0, which y equals 0 is the x-axis. Okay, I'm going to try and bold it here. And then it also says x equals 2. Okay? So we can clearly see a shaded region, a little point of intersection there.
Was it too front, is it more like that?
The 2 in the front just makes it stretch.
Yeah.
It doesn't make it move.
Fatter or?
So it makes it taller and skinnier when it's a whole number. So here's the scenario that's going to happen for all 4. Now they're just going to say rotate around here and there and so on. Okay? So A says revolve around y-axis. This is part A. Revolve around y-axis. Now, if I say revolve around y-axis, what is my C?
Oh.
It's x equals, specifically x equals 0, to let me know that this is one of the nice ones. This is one of the bad ones, just kidding. So it's going to be annoying, but I am going to redraw that graph every single time, okay? So x equals 0, the y-axis is right here, okay? So this entire thing is going to rotate. So I need to figure out my A to B, and then I can clearly see my closer R and my further R, okay? So how do I find out what this number is here? Because I know my A is 0. What's my B? Yep. A equals 0. B. So I need to set the function 2x squared equal, not equal, sorry. I got to plug in the 2. That's an x.
So it's 0 minus C.
So I need to find y at 2, which would be 2 times 2 squared. And that gives me 8. So that's my B. That's what this number is right there. Okay? The second thing I need to do before I can solve this is rotating horizontally. So I need everything in terms of y. So y equals 2x squared. I'm going to divide the 2 and square root it. So I have x equals square root of y over 2. Okay? So now I have pi times the integral from 0 to 8 of c is 0, so I do not have to write my c, but I am going to have the bigger, further r, which is just 2 squared, minus the closer function in terms of y, which is square root of y over 2 squared dy. Yeah, and you're done with the hardest part.
Wait, the first one, they couldn't cancel out, right? So
Remember, we're rotating right now around this line.
oh, so they're doing negative.
So technically my c is 0, so I don't have a c. Just gonna start redrawing the graph for the next one. All right, how are we doing with A? All right. So B now says about the x-axis. Now, x-axis means you put your line horizontally, your hand horizontally, and what I'm rotating around is right here. Okay? So if you look from the x-axis, I only have one function to go to, and I can see that my A is 0 and my B is 2. This one should feel real nice and easy. Okay? So x-axis means that my C is 0. My setup should be nice and short, from 0 to 2, everything in terms of x's. I see a 0 and I don't have a second function, so I literally just put the one function, which is 2x squared, squared. Okay? Should feel nice and easy. Make sure you distribute that squared to both the number and the variable. I'm sorry? It's the same exact equations. The only thing I'm changing is what it's rotating about. All right, 128 pi over 5. All right, moving on with C. C says, all right, we're going to get a little more complicated. C should be the most complicated it gets. It says revolving around the line of y equals 8. Yeah, it's the ugly one.
It's a nice one. It's a nice one.
Oh, you're right. It is a nice one. It'll be the next one. So that tells me that C is 8. Okay. So y equals 8 is right here. And this is what we're going to rotate about.
What would you do with those two, like the line there? Would you,
It's just going to tell you your boundary from where to look. Okay?
So you don't include that under your, like, integral then?
It'll be part of my limits, like my A to B. Okay? So we can see my closest function, whoops, which is my little r, and my furthest function is the x-axis, my furthest one. Ah,
Oh.
a little harder to see, right? And then it does go from 0 to 2. Okay, so be careful because we have a C and we have two functions. So we are filling out the full equation here, okay? So I have C, which is 8, minus the further function, which the further function is what?
It's 0.
0.
So,
And then minus C, which is 8,
minus 2x squared.
right, minus the outer function, which is 2x squared, squared.
How about that?
No on.
That's why I hit from 0 to 2 is the top is 8.
So remember, when I'm revolving this way, up and down, I need to find my limits based off of left and right. Does that make sense? So, rotating around, up and down, my functions are going to give me that limitation. Now my A to B needs to be sectioned off by the numbers side to side. Look at my hands really quick. When I rotate up and down, I need to block it off A and B on the sides. When I rotate side to side, I need to block off A and B with the Y's. Make sense? So now I have 8 squared, which is 64. Make sure to keep this negative here with parentheses before I clean this, because I'm going to have to distribute. So this should give me 64 minus 32x squared plus 4x to the 4th. Do you guys remember how I'm doing that so fast? That formula from algebra? A squared plus 2ab plus b squared. That's how I'm doing it quick, okay? Be careful, again, huge mistakes that happen every year is forgetting to distribute that negative.
Yeah, I canceled, so 64.
Whoops, I put it on the squared. Right, so now I have 64 minus 64 plus 32x squared minus 4x to the 4th. Boys. Yeah, which is nice.
8 times 32, 3,000.
Oh, that's good.
Why, what did you do? And I like putting my terms in order according to the exponent. You don't have to, it'll still give you the same answer.
Oh, that's right.
Just a personal thing. Yeah. Simplify what? Fractions? Math, frac.
Would you have to put the minus 0 on that fraction?
If I'm being honest, I've never heard the answer to that question, so I don't feel confident giving it.
I mean, I assume not.
Yeah, I want to assume that, but I don't like assuming those things. So I've assumed wrong before. How are we doing? 55 minutes, exactly. All right, last one for these equations. It says D is revolving around the line of x equals 2. So that is my C. Okay? So x equals 2 means I'm revolving around this guy. Okay? So if I'm revolving around this line, I have one function to worry about.
Give us like another x as a 0, right? So you
Right. So I only have to use one function. And then, so if I'm revolving horizontally, that means I need to look vertically from 0 to 8. That means this is one of those equations that my function needs to be in terms of y.
So it goes from 0, like the interval goes from 0 to 8, and then the C is
Exactly. Exactly.
So the interval would be pi to 0 to 8.
All right. So I only have one function, so I'm going to have my C, which is
2 minus
good.
square root of y, which is
Good. Remember that function we had written previously? We had said the function was
equal, well, in terms of y.
right. Not going to lie to you, this is an ugly problem. Okay, we'll probably leave it messy like an FRQ style. And then again, this is dy.
How come we don't put the other half of the equation?
I only have to put the only other half if there's a second equation. Because the first equation is the actual line that I'm revolving around, it cancels out. Like on,
Oh, x equals 2.
yeah, we did one of those, I can't remember which one.
X equals 2 and then C is 2.
Yeah.
Exactly. All right, so this does get ugly, okay? Have 4 minus 2 square root of y over 2 plus y over 2 dy. I'm sorry, this isn't a 2, this is a 4. It's minus 2ab, so I have to double the 2. Guys? Okay. So now, this is a little bit of u sub in here in this middle term. That's why this one is really ugly. So be careful. This is like saying 4 times half y to the 1/2. Okay? So my u is half y, and my u prime is half. Okay? Does that make sense? So,
Necessary to do that one.
yes, because you're going to have to, I need a half in the front and I have a 4. Okay? So be careful. Be very careful there. So I'm going to have so if I'm missing a half, you can ignore the 4 and just pull it out for a second. I'm missing a half, I need a 2, so that 2 times that 4 that's there is 8. Okay?
Are you doing the integral already?
Yes, I am doing, oh, I put the sign. Why do I keep doing that? Sorry, guys. Baby brain, I know. So again, I'm missing a half, so I put a 2. 2 times the 4 is 8. Now, add 1, it'd be 3 over 2. And then, wait a minute.
Do 2 over 3, not.
Right, here do 2 over 3. And then whatever's on the inside.
Would the 8 still be there then?
It'll simplify now in a moment. And then I have 3 over 2 plus 1/4 y squared. And this goes from 0 to 8. This one? So I had a 4 here. If I was missing a half, Because the derivative of the inside would be 1/2. Technically, I'd need to put a 2 outside, so the 2 and the 4 make the 8.
Oh, and then see if you want it.
Okay. So this is a really messy f of b minus f of a. I'm going to have you stop here. If you put it in your calculator, it should give you 16 pi over 3. They would never, on the AP test, have you waste time with so much arithmetic. Okay? Technically, if we have to go one more step, because they do give you credit after the f of b minus f of a, we'd say 4 times 8. And then literally, don't even worry about multiplying all these numbers. You don't want to make a little mistake. And then you can go there. Okay? All right. How am I doing with time? 10 minutes? All right, slide 19. A manufacturer drills a hole through the center of a metal sphere of radius of 5 inches. Okay? The hole has a radius of 3 inches. What is the volume of the resulting metal ring? You know what, guys? Sorry, I'm going to skip this one.